Let us talk about operators in C++. Operators are symbols which indicate a specific operation to be performed. Not too complicated, I'll tell you what it means. Plus is an example of an operator. Minus is an example of an operator. Star is an example of multiplication. Forward slash is an example of division. So these are all operators in C++ language. These symbols indicate a specific operation to be performed. For example, plus indicates add two values, minus indicates subtract from them, and so on. So these operators are symbols that are used to perform specific mathematical operations like addition, subtraction, multiplication, division, and so on, or logical manipulations. What do you mean by logical manipulations? True, false, greater than, lesser than. All these are examples of different logical manipulations you can perform. Left shift a bit, right shift. These are all examples of logical operations. C is C++ is extremely rich in the number of built-in operators it has. It has almost 45 different types of operators used to perform different operations on the data known as operands. Now there are different type of operators. Some operate on a single operand, some on two, some on three. So therefore we call operators as unary, binary or ternary operators. Let us try to understand what is the meaning of this word unary, binary and ternary. Suppose I have something like this. I declare A as 10, B as 20, C as 0. And if I say C is A plus B, here plus is acting on A as well as B. A is the first operand, B is the second operand. This is called as an operand, this is called as an operand. Adding these two, the result goes into C. So since plus is acting on two fellows, it is called as a binary operand. Now let us say I do something like this. I say C is equal to minus of A. Now this minus is acting on only a single value or a single variable A. Therefore, minus in this case is an example of a unary operator. This is a binary operator. This is a unary operator. So A and B are operands. Minus and plus are operators. We'll discuss ternary operator in the next few sessions. So let us understand the meaning of what do we mean by expressions. Suppose I write something like this. C is equal to 2 into 3 plus 5 plus A. An expression is a combination of operands. 2, 3, 5A are operands and operators like multiplication, addition and so on. The evaluation or the solving of which leads to a single value. If I solve this, it is 2 into 3, 6. 6 plus 5 is 11. 11 plus A is 10. So 11 plus 10 is 21. So C is equal to 21. So an expression is a combination of operands and operators, the solving or evaluation of which leads to a single value. So in this case, 2, 3, 5A are operands. These are operators. When you solve them, you will get a single value. This complete thing is known as an expression. Even this is an expression. This also is an expression, because if you solve, you will get some value. Solve this, you will get some value. Now sometimes an expression may also be something like this. C is equal to square root of B. So this is also an expression, because this is an example of a function call. I am passing the value of B to a library code called as square root, which is calculating the square root of B and copying it over to B. Now this should give you an idea about what are operators. Operators are, think about it as plus, minus, multiplication, division, and logical, true, false, greater than, lesser than, and so on. Now let's first try to just glance over a little bit of the unary operators. Okay, we're not going to dig deep, because all this you're going to learn as you proceed. It is not required to mug up this particular table or remember any of these unary operators. You just need to know their functionality or how they work. The functionality of all of these operators you will learn as we proceed to learn different things in C++. Don't think that you are required to mug up this table and reproduce it. Unary operators, as I told you, operate on a single operand. A is an example of a single operand. Minus is operating on A. So in this case, minus is a unary operator. They get evaluated by before anything. Suppose I say something like this. Suppose I write C is assigned minus A plus 2 into 3. First this will come into picture. Minus A is, this becomes minus 10, plus 2 into 3, 6, minus 10 plus 6 is minus 4. So unary operator gets evaluated before any other operators get evaluated in a expression. Examples of unary operator are logical not, pointer operator, address, unary plus, unary minus. This minus was an example of a unary operator. Now there's a complement operator. Complement, what it does is everything is stored in binary. What a complement does is, if it is ones, it makes it zeros. If it is zeros, it makes it ones. Suppose this is a decimal number 0. If I do the complement of it, suppose this is represented as 8 bits, so it will be represented as 8 zeros. When I do a complement, all of those bits, okay, assuming they are 8 bits, forget this, will get converted into, all of these 8 bits will get converted into ones. Complement means make 0 as 1 and 1 as 0. So you have a number of different unary operators. The more important ones of them are the prefix increment, the prefix decrement, postfix increment and postfix decrement. We shall talk about them now. So let's try to understand what we mean by this increment, decrement and all this stuff, because this is really important. So suppose x is 8. If I say y is equal to minus x, then y will get the value minus 8. Here minus happens to be a unary minus operator. Then take a look at the next one. Now I have something interesting. I have x equal to 1. Plus plus is an example of a unary pre-increment operator. When this plus plus comes before the operand value is increased and then that new value is assigned to y. So if you do something like this, int x is equal to 1, int y is equal to plus plus x, y gets the value 2 because the value of x is increased by 1. The new value of x is assigned to y becomes 2. Of course, x also ends up becoming 2. Plus plus means the value of x is increased by 1. Now let's understand unary. This was pre-increment. Let's understand post-increment. This is through another example. X is 1, y is x plus plus. Here what happens is the value of x is modified after the semicolon. Since the plus plus is after the x or after the operand, the value of x remains as it is and it is copied to y. So y remains or gets the value of x, which happens to be 1. After the semicolon, the value of x ends up becoming 2. This is an example of unary post increment. Now let's understand decrement. Unary pre-decrement. Decrement means reduce. X is equal to 1. Y is equal to minus minus x. So this is minus minus is before the x. So x from 1 will first become 0. That 0 will get copied to y and x also becomes 0. So everything happens before the semicolon. Now understand unary post decrement. X is equal to 1, y is equal to x minus minus. So the value of x is going to change after the semicolon. So y will take the old value of x, which happens to be 1, and x will become 0 after the semicolon. So we will be using these increment and decrement very frequently. Make sure you understand these unary operations very well. Take a look at this example. You will easily understand it. Now let's understand this through an example. X is 20, y is 30, z is 0. I am saying plus plus x and plus 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 y plus plus. Since the plus plus comes before x, x will first become 21. Since the plus plus is coming after y, y will become 31 after the semicolon. So this is as good as adding 21 plus 30. 21 plus 30, z will be equal to 51. But both x will be 21 and y will be 31 after the semicolon. Here the difference is the value of x changes before the semicolon. Here Plus plus indicates the value of y changes after the semicolon. That is the fundamental difference between pre-increment and post. Pre means do the increase before, post means do the increase after the semicolon. Pre-decrement, reduce before semicolon and take the new value and give it to the left side. Post decrement means reduce the value after the semicolon, give the current value to the left side.